Yes, thank you everyone for attending this talk. I'm Daniel Montoya, and I'm gonna be presenting under Jetpack Compose and Arrow. Little bit of myself, I joined 47 Degrees in September, together with my friend Alberto. And before this, I was working in Amsterdam, in the Netherlands, and I worked for Mobgen, Accenture, and Label A. And now I'm back in Spain, in the south, enjoying the sun. The summary of this talk would be covering what is Jetpack Compose, how to build UIs with Compose, and I'm going to show some basic examples. And I'm going to explain how to manage the state within composable functions, also showing an example. And to finish the talk, I will walk you through a simple architecture I have built, showing the typical list of elements, and then going from the list to the detail screen. And I'm going to be using all this technology, so Compose, Arrow, View Model, Dagger, Navigation Component. And I added them here just to create some hype, so you stay with me the whole talk. So what is Jetpack Compose? Jetpack Compose is a modern toolkit designed to simplify UI development. So same as Flutter, Swift UI, or React, this is fully declarative. And we will be writing less code for sure, because now we won't be writing any XML layouts to represent your views. We will be writing or designing our UI elements using intuitive Kotlin APIs. And we are also backed up with powerful tools like Preview and some others. It's fully declarative, so the UI hierarchy will be based on calling some other composable functions. It uses the reactive programming model. And of course, it's fully compatible with your existing application, both Java or Kotlin. But what makes composable possible? So this is possible thanks to the new Kotlin compiler, the Compose compiler plugin, and the Android Studio preview build. And also thanks to the Compose UI material, foundation, core, and runtime, and other artifacts, we will be able to create amazing applications. So currently, the views have their own state. So when designing a new view, we have to create our XML, and then to changing or alter the state, we will be having the Java or Kotlin file to do it. But now with Compose, that state is removed, and the UI components will be designed based on some input to be rendered, and that's it. Let me explain myself with an example. So the first key concept I'm going to be explaining is the difference between declarative versus imperative, meaning what we would like to see versus how to achieve it. This means that we will be describing the UI for any value independently of the previous state. So if we want to represent or update the count of this example, this is how we will do it in the imperative way. So we will have to update the unread messages component, and based on the count, we will have to check if the count is greater than 0 and has no badge, add the badge. But if the count is equal 0 and has a badge, remove it. But if count is greater than 99 and has no fire, add the fire. A mess, right? So we can do it differently. In the declarative way, this is how we will do it. We will create our composable function, and we will compose our envelope with our badge. And this is it. This is how we will do it. Depending on the input, the count, we will show the envelope, and the envelope will be empty or with some paper or with paper and fire. And depending on the count, if it's 0, we won't draw the badge. And if it's greater than 0, we will draw the badge. And depending on the count, we will show the count itself or 10 plus. Easy, no? So we can see already that we can mix any sort of language feature from Kotlin, like if statements map over your list of data or any others. And functions are composable through the lambda parameter. So if we see here the envelope, through the lambda parameter, we are composing the children's, and if the count is greater than 0, than 0, this batch will be rendered. Much smarter, right? So, but let's get on how to build UIs with Compose. So a Compose application is built out of composable functions. These composable functions will be annotated with the @composable annotation, and that gives us the power to call other composable functions. And these composable functions will take some input and just decide what UI to show based on this input. This will be the first thing to learn, right? On any new thing you are learning. Hello world. So this is how we will do it in Compose. So we have our function annotated with the @composable annotation and has some input, the name, and we will render this text based on this name, right? Easy. Let me show you some more examples. The preview example 1, we can see the preview at the bottom right, and it says, hello, Kotlin folks. It's very easy, but maybe we can say greetings to all the 47 degrees offices. But in the preview example 2, we can see that all of them are getting overlapped. So how can we fix that? In the preview example 3, we can see that calling the column composable function, we can place all the greetings one after another, and that will be fixed. And the column, the composable function column, will be the equivalent of a linear layout having the vertical orientation. Easy. But how do I call my composable functions? Because in Android we have the activity. So how they hook up together? So when using this set content function, through the Lambda parameter, whatever is inside, that will become the root of our activity. So instead of calling the set content view and the XML layout, we have this extension function that will hook up with our composable world. So what is doing this function? As I said, whatever is in the Lambda parameter, it will become the root of the given activity. But keep in mind that we are depending still on the activity lifecycle. Summarizing, the idea is then build reusable composable functions, also called UI widgets. And keep in mind that each composable function is responsible of the functionality that it encapsulates. So for testing and so on, it's quite handy. So let's build the unread messages example. This example is showcased in the talk from Lila Richardson. So I coded it just to practice a little bit. But to keep the account updated, we need to have some knowledge to see how to manage this state, right? And that brings us to the next topic. So to manage this state, Compose offers tools for observing changes in our data, and which will make our functions to be automatically reinvoked. So Compose also looks at what data is needed for each composable function, and if these functions are using this data, when this data has changed, it will be reinvoked, and the UI will be rendered again with this new value. But for other functions, maybe in the same scope that are not using this value, they can be skipped and they are not affected, so they will stay as they are. So how do we manage this state? So the basic recomposition will be using this state function. And when we call this state function with this initial value, for example, 0, we'll return two components. The first component will be the counter state representing the value. In this case, initially will be 0. And then the other component will represent the callback that is the function to alter this state. So knowing this, if we want to render the batch envelope, we need to use this counter state value. And based on this value, we don't have to, as we said before, we don't have to keep into account the previous state. It will be rendered with this input, and that's it. And to modify these numbers, I have created two buttons, one to add emails and another one to delete. And through this button, using the counter state callback, we will be able to alter this state. And what this state function does is we are passing an initial value, and this value will be remembered, memoized, or cached. And whenever we call these callbacks to alter this state, if this value has changed, we'll make all our composable functions to re-invoke and re-render with this new value. So the state in composable functions flows down via the parameters, as we've seen, and the state changes with the callback flow up via the callbacks. So basically, all the state that we want to use within our composable functions should be exposed, because it's the only way that can be consumed or controlled. And this pattern is called state hosting. And this will make our component easier to test, reusable in different contexts. So let me show you some examples. Oops. So if we want to see the inbox, this will be the example I was showing in the slides. So we can also preview this state with 5 emails in the design view. So we don't need to run the example to have a quick look to how it will look. And with this annotation is how we can preview it in this site. If we want to preview any isolated widget, we don't have to pass any input here, because widgets are deterministic, so they are based on an input. If we are depending on some input, yeah, we cannot preview it. We have to instantiate it with some particular case. So to compose this batch envelope, we can see here, this is what I showed before. I hope you can see the code well. We are rendering an envelope with the count, and through the lambda parameter, we are adding a batch or not, depending on the count. So basically, the envelope will be your container, let's say, and we'll draw inside in an image an empty envelope, an envelope with some paper, or an envelope with full and fire. And we are also making some room with another container or box to place these children that, in the case of the batch envelope, we will compose it with the batch. So this is, when we render the UI, this is how we will place the batch here. And the batch is simply a surface with a red background and some rounded corners and some text. So if we want to compose, as I said, this is how we would do it. The envelope and compose the batch within the lambda parameter. And besides using the state in the structured way with these two components, we can use it also in a different way. So we can use the mutable way, which would be creating a class with some variables. And this class should be annotated with the add model annotation. And we can see in another example I created, we are doing the same thing, but using this counter state. So we will pass this input to the batch envelope, only the count. And for the other components that want to alter this state, we will have to pass the whole object. And if we want to alter the state, we can do it like this. Just access to the variable itself and do ++ or minus. And that's it. That's how we will manage the state. And okay, now that we know how to create simple composable functions, we know how to manage the state, I think we can jump into a more advanced example. And I have created this basic architecture example. You might be familiar with this diagram already because it's the recommended Android architecture. And I changed it a little. So in my example, I will have still the activity where I'm setting up the navigation component, and I will use fragments. But this within the fragments, the view group also has this extension function set content, and through this function is where I'm composing my composable functions. So, but still the architecture remains the same, and we are only replacing this way of creating our UI. So the fragment still will be calling the view model. The view model will execute our use cases. So these use cases will use the repository, and the repository will fetch some data from the network, then store it in the database, and will be returned back to the view model, where we will update the live data. And this live data is being observed by our composable functions. And whenever this live data changes, our composable functions will be recomposed, and they will update the UI. That's it. Let's see if I can guide you through the code. So to build this, I'm using Jetpack Compose, the latest version, the Dev 10, and I'm also using the latest version of Arrow, just to show some of the new APIs in the new module we have built for ArrowFX. But Alberto will show us more in the next part of the talk. And I'm also using some other libs like Dagger, Navigation Component, SQL Delight, Retrofit, Moshi, just to have a taste of a complete example. So let me try to guide you through the code. So everything will start in our application class, where I'm setting up Dagger. And yeah, I'm using Dagger, but I could have been using any lazy objects or coin or whatever. But I'm using Dagger now, where I have the view model module, where I create I provide all these view models. I also have the network module where I set up Moshi, Retrofit, and so on. And I also have the data module where I'm providing the repository, I'm creating the data source for the database, the network data source. Okay. So that's the dependency injection. Then the entry point of our application will be the main activity. As I said before, I'm still using this set content view because, yeah, for now, Compose is not ready to have their own way to handle the navigation, and there are no plans to do it very soon. So I think ideally we should stay playing with the navigation component, which is quite easy to use. So the activity will be only the container, and will host the navigation graph. Through the navigation graph, we can already see a whole picture of our application. And we see that the start destination is the repos fragment. And whenever we click on one of the items, we'll navigate to the details. So starting from there, this will be the Arrow repos fragment, which contains the Arrow repos view model, and also hosts our composable function. So as I said before, through the view group, we have the set content extension function, right? And the recomposer current is meant to be kind of the main thread. And in here is where we are setting up our composable function. But let's not get into this yet. So the view model, this hasn't changed. I'm using live data, but you can use Rx or Flow or whatever you want. And I'm initializing this live data with an initial state. So the first thing that we will see in the app when we run it is this loading circular run. I don't know how it's called. Oops. Well, spinner or whatever. And yeah, this is the initial state. So when we call this arrow repo screen, it already comes with an initial state. So this state is the loading state. So we will be showing this loading view with the circular progress indicator. That is. And after that, we are telling our view model init. And this init is basically executing our task to fetch the data. In this case, we are calling this get arrow repos function. And this get arrow repos function will call our use case. And basically our use case is creating an FX block where we will be switching to the IO thread. And we will be binding our effects. And whenever we get a result, we will again switch to the main thread, and we will update our live data with the error or the success. So when calling our repository will be the one engaged to fetch from the network all the arrow repositories, and we will do it through our client. Our client is basically a retrofit and will return the list of repositories, right? So whenever we get this data, the next step will be inserting all the repos we got, and then we will fetch from the database all the repos. And in case if anything happens, this is how we are handling the error. So if we had previously something in the database, do the select and return it. So whenever we are done with these steps, as I said, we will switch back to the main thread and post the value. And since our composable functions is observing from this data, if we get some data, we will get to build the repository list view. And let's check what is this. The repository list view basically gets a list of repositories and some actions, right? The actions are meant to be when we want to navigate from the list to the detail, right? So to render this, we have created this vstack composable function that has a vertical scroller, a column or linear layout to place the child vertically, and we compose it with all the childs. These childs will be all the repositories that we got from the network, right? So we can map over our data and create all the repo views. And this is how it will look a single item. So our repo views are clickable. So to make them clickable, we have this composable function with some modifiers and the onClick method. And as we said before, a state flows down via the parameters, and the events flow up via the callbacks. So this will be a callback set up in our fragment. So whenever we click this repo, the fragment, the event will flow up until the fragment, and is the fragment the one engaged to do the navigation from the list to the details. And yeah, this is clickable, but to show and render the view, we have this design, right? So we have a column. So we will place one item after another, like in a column. And then the first item in the column will be a row. So this will be the equivalent of a linear layout horizontally. And we have this arrow image with some text. And then the next item is the arrow meta. And then the next item is the description. And then the next item is a row with the language used and some stars. And that's basically one item. And that's how we compose the whole list of elements. And then if we want to click on one of the items, As I said, we have this callback set up in the fragment that will handle all the actions for all your components. In this case, we only have the repo actions, and the repo actions comes with the repo click, and this will make to navigate with the navigation controller to the next screen with these parameters. That's it. Basically, that's the whole architecture. So I wanted to show also how this new APIs in Arrow works. So because it's pretty interesting that we can launch our IO operation using this view model scope. The view model scope is the coroutine scope that has the view model itself. So whenever this view model gets canceled, we cancel automatically our IO operation, so we don't have to do anything. And by using Arrow, we get a lot of other powers that for sure Alberto will explain later. But this is what I wanted to show, that there are these new APIs that are very handy and plays very well with architecture components that already provide this scope. And another way to use this API, it's the same, but I have created an example also to do it the other way around. So we can, from here, we can see that given an IO operation, we can do unsafe run scope depending on this view model scope, or we can do it the other way around. Meaning from the view model scope, we can say unsafe run IO and pass here the IO operation. So I think it's a pretty simple architecture, but I think it's covering many of the problems that we have in Android. And it's using the reactive programming model with live data, but you could have used RX or Flow. And they also provide some handy APIs to observe. In the case of live data, is observe as a state, but if you use RX, you can say subscribe as a state, or I don't remember how it's done in Flow, but very similar to this as well. And yeah, let me run the application and see how it looks. Also, if without the need of running the whole application, you can also preview. Let me see, where is it? Here. Without running the application, you can actually run this composable function and will be rendered in your phone without the need of running the whole thing. Okay, we will see first the loading. Then we are fetching from the network, storing in the database, and we get the result. And whenever we click in one of the items, we can see the details. And this works, and this works, and everything works with the navigation component. And that's it. Yeah, I didn't show the inbox example, but let me, just to confirm what I said, you can preview the example without running the whole application. I just click here and I say, hey, run this, and let's see how it looks. Yeah, so we can delete emails, or we can add emails, and it works pretty nice. And that's it. Just to recap a little bit, there are some wishes because orientation changes is not ready yet, navigation is not ready yet. So that's why I went for the navigation component, but they are working on it. Jetpack Compose is not production ready yet, so it's still being polished. So keep that in mind, that anything I said it can be prone to change. It interrupts pretty well with your existing app. As I said at the beginning, you can use composable functions in your views and vice versa. It uses the reactive programming model with live data, Rx, or Flow. And that's it. These are some links and resources I have visited before preparing the talk. And that's it. Thank you.
Thanks, Dani. You want to go to the Q&A?
Sure.
Yeah. Can you switch to the Q&A? Just one thing from the chat. They're asking if it's on your GitHub, the repo that you used for the presentation.
It's not in my GitHub. It's in the 47 degrees repository. So I don't know where to share the link, but
okay, we'll share it later. We can share it later on Meetup or on Twitter. Yeah, it's good.
Cool.
Can you see the Q&A?
Yes. Any tips about testing? I haven't dig into it, but yeah, for composable, I haven't dig into it, but for the rest of the architecture, I haven't changed anything. So you can still use all the unit testing that you were using before. So another question. Isn't this way more verbose than an equivalent XML file? I'm thinking on adding shapes and ripples for the button, and it will be even bigger. No, it's not more verbose. And the way to create your UI components using Compose will be like everyone is a library developer, right? So when designing your UI components, you will be like creating your own DSL where you can pass through the inputs whatever you want. And in case you want to modify something, there is this modifier element, and you can change all the operations you want to modify. You can add shapes, ripples, or whatever. So it's much nicer than having in one side the Kotlin or Java file and then the XML layout, and then through the Kotlin file changing its state or doing stuff. Everything is linked together, and you can use Kotlin, so it's quite nice. Okay, more questions. Is it possible to change the thing at runtime? Yes, I think so. I haven't tried it, and I don't know if it's available yet, but it will be possible if it's not already. I have seen another question. I have seen that the public API of Compose changes a lot from version to version. Did you find this annoying or slowing you down when playing with it? A little bit, but yeah, this is mentioned in all the talks. They are still polishing a lot of things, and they are modifying all this stuff. So everything is prone to change, and you should be aware of that. So yeah, you have to deal with it. But still, when they change the API, they are also deprecating the old components, and usually with command option you can find the option to replace with, and or maybe through the documentation you can see what to use. Because for example, in the envelope I was using when I created 2 months ago, I was using container, and this container now it got renamed and now it's called box. So yeah, but it's very prone to change, so you have to deal with this. Another question. Do we have more time? How hard?
Yeah, we still have 5 minutes, so you can finish all the questions. Yeah.
So how hard is to specify view constraints within Compose? It's pretty easy. As I said before in another question, you can, through the modifier, parameter, you can change all the constraints you want. I don't know how it's done in Flutter, but this seems pretty nice. Another question, do you have the feeling of Compose making code harder to read? I find MVP pattern with external XML way easier to follow. Maybe I'm just used to it. Yeah, maybe when you are used to some architecture, the change is hard. But no, I don't know if you've seen the example I've shown before, comparing the declarative way and the imperative way. For me, it's way easier to read the declarative way, where in one look you can see what your state can be, right? So for me, it's nicer. Another question. Did you find it easier to play around with Compose by having an arrow background? If I found it easier, well, no, it doesn't matter. It doesn't matter. You just need to shift a little bit the way of thinking, and just by doing some code labs or some example, you get there, and you easily get used to it. So I like it. More questions. This question relates to testing a little bit. It seems that coding UI programmatically might tempt people to mix business logic and UI together. Yes, but um, also also helps to define your UI in a way that you don't depend in the previous state, right? So I think it's much nicer to do it this way. And what else? When you were mapping the repo items to a list of views, is that using recycler view or creating all the views at once? Uh, no, I'm not using the recycler view. I was using a VStack composable function that I have created, and this VStack is basically a vertical scroller, and inside of the vertical scroller I have a column, and inside of the column I have a placeholder for all the childs. So when we are mapping over the list, we are creating all the childs, so all the views that will be hosted by this vertical scroller. So it's pretty easy to build. And that's it. There are no more questions.
Cool. Thanks, Dani. Thanks so
You're welcome.
much. So
I hope you liked
it. Absolutely. It was really cool. I would like to thank all the people who give a clap and give feedback on the YouTube chat, because not being here, not being like live and not like with the people, it's quite difficult to have feedback. So thank you very much.